analyze the following equation. So I'm going to give you an equation. This equation based on our note is x minus y squared equals to 1. So what type of symmetry do I have here? What is it symmetric to? Remember that if x and y is on the graph, then you can conclude that x and minus y is on the graph, you have symmetry with respect to x-axis. If x and y is on the graph, minus x and y is also on the graph, you have symmetry with respect to y-axis. And if the point x and y is on the graph, minus x minus y is also on the graph, you're going to have symmetry with respect to the origin. So what are we going to do? We're going to switch y by minus y. If we get the exact same x value or the same equation, then we're going to say that we have symmetry with respect to x-axis. To check symmetry with respect to x-axis, let us substitute minus y for y. So remember that the only changes that you have is the negative sign in front of your y. So if I substitute negative y for y and I get the exact same equation back, then it means that I have symmetry with respect to x-axis. So I have x, I have subtraction, I have y raised to second power, but my y is now substituted by minus y to the second, and on the right-hand side, I have a 1. So take a look. I get x, subtraction, minus y times minus y is positive y squared. So you get y squared equals to 1. So compare the original equation with this new equation. They are basically the same thing. Since we have the same equation, it is symmetric with respect to x-axis. Take a look at another example. So this is the very first equation. Let us take a look at the second equation. Now I'm changing the sign here. X plus y squared is equal to 1. To check symmetry with respect to x-axis, we just need to switch y by negative y and do the algebra and see if we have the original equation or not. To check symmetry with respect to x-axis, let us substitute minus y or y. So x, I'm not changing x at all. I just need to change y. Plus. Instead of y, I'm using negative y to the second power equals to 1. But negative y times negative y is positive y squared. I get x plus y squared equals to 1, which is basically the same equation as I had before. Take a look at this one. So let us check to see if we actually have symmetry with respect to x-axis or not. So let's go back here, erase this. X minus y squared is equal to 1. Wow, take a look at this. I have symmetry with respect to x-axis. The exact same piece is on top and on the bottom. And it's symmetric with respect to x-axis. What about the second equation? My second equation was x plus y squared equals to 1. Wow, this is my second equation. Again, this is also symmetric with respect to x-axis. For any random point that you take on the graph, just move this a little bit here with a nice point. If it stops somewhere nice, it doesn't want to stay here. That's fine. So if you take any random point on the graph, its opposite, y-axis, y values is also on the graph. The same for your blue graph, which is for the first function. If I take any random point here, x and y here, and if I move that down, I get the exact same x value with a negative y value. Okay. So we just prove it algebraically and also geometrically.